All right, Mr. Ahmed here for 5.5. Goal for today is still to prove triangles are congruent. We're going to learn two other shortcuts besides side angle side today. And the first one's going to be side, side, side. So our essential question is still, how do I prove triangles are congruent? How do I prove triangles are congruent? So side, side, side is our first theorem that we're going to use today. And the side, side, side theorem just states that if three sides of one triangle are congruent to three sides of a second triangle, then those two triangles have to be congruent to one another. So since the three sides are congruent, that would then tell us the triangles are congruent. So that also would inform us that the corresponding angles would be congruent. So what we're looking for when we're looking for side, 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 tick marks on the side. We'll also use the reflexive property quite a bit. We'll also bring back some terms such as midpoint and bisectors as well. So in this diagram, we have triangle ABC and RST. They have three pairs of congruent sides. So when I name them, I have to make sure I put the corresponding parts in the correct order. So as I look at this, if I name the first triangle ABC, I'm going from one tick mark to two. I would need to do the same thing on the other triangle, one tick mark to two. You can choose to name it however you want. You could name it CAB or BCA. Just make sure you put the corresponding parts in the correct order. So I'm going to stick with ABC. So triangle ABC, that's one tick mark to two. I need to do the same here, so that would be RST. All corresponding parts, same order. So we're going to hop right into a two-column proof. And this is kind of where we're hoping to master our proof process is in these triangle proofs. So I need to prove that the two triangles are congruent. In order for me to end these two-column proofs, I'm going to have to end with one of our shortcuts. Side angle side, which we already know, or side, side, side. As we progress through the rest of the chapter, we will find a couple others. Keep in mind the swear word is the one that does not work. So starting with our given. Given number one states FJ is congruent to HJ. So I have two congruent segments. As we use these givens, we need to make sure that we mark it in the diagram. So FJ, HJ, there's already a tick mark there, so we're good to go. When I'm just given that it's a congruent segment or a congruent angle, there's really not much else I can do with that given, so I'll move on to the next given. So my next given says G is the midpoint, I'm going to abbreviate midpoint, of FH, given. So now, since I'm given a keyword midpoint, I'm going to have to use this given, all right? When I look at the diagram, if G is the midpoint, that tells me that these two segments are congruent because it cuts the whole thing in half. So that's going to be my next step. I need to write in that those segments are congruent. So step 3, FG is congruent to GH. And the reason is we use the midpoint. So it's definition of midpoint. All right, so now we have two pairs of sides that are congruent. So I put an S and an S. Now, that's not enough. We need to show that all three sides. So when I look at this triangle, that side in the middle, that's a shared piece. So it is congruent to itself for both the triangle on the left and the triangle on the right. All right, so I'm going to put some tick marks on that just like we have on a couple of the other problems. 1, 2, 3. Notice I use 3 because it's not the same length as the other two. So now I need to include that in the proof though. I need to say that JG is congruent to JG. And if something is congruent to itself, we are using the reflexive property of congruence. And POC is how we abbreviated that, reflexive property of congruence. And finally, wrapping it up, we can now state that the two triangles are congruent. So step 5 is where we're ending. This is exactly what we're proving. Triangle FGJ is indeed congruent to triangle HGJ. And the reason that we finished it is side, side, side. And that's all we got. So we finished our two-column proof. Next couple examples just state whether the congruent statement is true or false. So when I look at this diagram here, keep in mind we have to see, is there anything else I can mark? I can indeed use the reflexive property, so this segment's congruent. We have a 9, a 9, an 8, and an 8. So there are indeed 3 congruent sides, so the triangles are congruent. And let's see that they named it correctly. JKL, so 8 to 1, it needs to go in the same corresponding order. MK is 8 to the 1 tick mark. That is indeed correct. So yes, it is true. It is true. And the reason is side, side, side. Now the next one. I have 2 congruent sides. I don't think I can necessarily assume that these other sides are congruent. So this one would be false. Reason why, I can't say that the triangles are congruent. All right. Next example, again, state if the 2 triangles are congruent. How do I know? So, is there another piece that I can mark? Yes, the piece in the middle is congruent for the triangle on top and the triangle on the bottom. So I would have side, 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 side. So yes, they are. Side, side, side. They are indeed congruent. And our next one, I have a side angle side, the included angle. Here I also have a side, an angle, and a side, but this is not the included angle. All right, it has to be the included angle in between the 2 congruent sides. This one's not in between the congruent sides, so this is not congruent. Can't use side, angle, side. The angle is not included. All right, the included angle. It needs to be the included angle. All right, another 2-column proof here. So we're going to have to use our givens and see if we can come up with enough to prove the triangles are congruent. So starting with our first given, step number 1, GH is congruent to JK. It's already marked in the diagram, so I just got to put that in. Reason, given. Start with our givens. Our next given says IH is congruent to IK. That is not marked, so IH, IK is getting 2 tick marks. IH, congruent, IK. Reason, given. And now our last given, we have that keyword midpoint. So we're going to have to use that keyword in this problem. So step 3, I is midpoint of GJ is given. All right, so this one I have to use. I is the midpoint of GJ. If I is the midpoint of G to J, that means these 2 segments are congruent. So 3 tick marks here. Have to name them. GI is congruent to IJ will be step 4. And the reason we used our midpoint again. So we used the definition of midpoint. I abbreviate midpoint. And finally, looking at our diagram, we now have enough to say they're congruent by side, 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 side. So I'm going to finish using side, side, side. And we'll write it exactly like we were proving. Step 5, triangle. GIH is indeed congruent to triangle JIK. So we finished another proof. Like we said, you're going to end these proofs with one of these shortcuts. Side, 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 side angle, side, etc. The next thing we're going to talk about is special triangles, which is a right triangle. And a couple definitions here. Right triangles have some specific parts, and one of those are the legs. The 2 sides that make the right angle are called the legs. The side that's across from the right angle, or the longest side, is the hypotenuse. All right, so if we have a right triangle and a pair of legs are congruent and the hypotenuse is congruent, then the 2 triangles are congruent. So this is a case where if you were working around, you would see angle, side, side, angle, side, side. Like we said, the square word doesn't work. However, this is a right triangle, so we can use hypotenuse leg, or I also refer to it as right hypotenuse leg, because it has to be a right triangle for us to use that. So if the hypotenuse and the leg of a right triangle are congruent, to the hypotenuse in the leg of a second right triangle, then those two triangles are congruent. So I could say that triangle ABC is indeed congruent to DEF based off of hypotenuse leg. So to use hypotenuse leg, there's three things we must show. Okay. First, I need to show that the hypotenuses are congruent. Then we have to show that a set of legs are congruent. And we also have to have right triangles. So we have to state that it's a right triangle in this process in order to use hypotenuse leg as well. Okay. So a couple examples here. Let's see what we got. So step number 1. Start with our given. QP is congruent to RP. And that is already marked. The tick marks are there. QP and RP have 2 ticks, so we're good there. Step number 2 on the given is that SP is perpendicular to QR. So we have to use this perpendicular. Okay, as we use the perpendicular, I'm going to be very specific in this process. Since it's perpendicular, I know that this is a right angle, all right? QR and SP are perpendicular, so these are both right angles because 2 perpendicular lines or segments intersect to form right angles. So I need to now state that these are right angles. So for step 3, I'm going to say QSP and RSP are right angles. Okay? So now that I've stated that they're right angles, the reason I used the definition of perpendicular lines or perpendicular segments. Definition of perpendicular. So now since I know that these are right angles, I can state that they are right triangles. So now when I state that they're right triangles, I'm just going to say triangle QPS and triangle RPS are right triangles. And the reason that I'm using is the definition of a right triangle. If a triangle has a right angle, then it's a right triangle. And now I'm close. Okay, I now have shown that they're a right triangle. I have also shown that we have a pair of congruent hypotenuses. However, that's not enough. I still need a congruent leg. So the piece in the middle that's shared for both, that is congruent to itself. So I can say that SP is congruent to SP for step 5. And the reason that we're using there is the reflexive property of congruence. Something congruent to itself. And finally, then we get to state that they are congruent triangles by hypotenuse leg. And I also like to include the word right hypotenuse leg because we had to show they were right triangles. So step 6. Triangle QPS is congruent to triangle RPS, and the reason is hypotenuse leg. Okay, so finished up that one. And we have one proof left. So let's see what we got here. Step 1, use our given. Our first given just states JK is congruent to NK. Reason. Given. JK, NK, those are marked. Step number 2, AK bisects angle JKN. So we're bisecting angle JKN. So JKN is being cut in half. That means the 2 little angles are congruent. So I am going to write that in my proof. Angle JKA is congruent to angle NKA. And the reason that we used is the definition of bisect. And we bisected an angle. All right, so now we have a side and an angle. One key piece left, the piece in the middle, congruent to itself. I need to write that in. Step 4, AK is congruent to AK. Segment signs above. Reason, reflexive property of congruence. And now we have enough information. Side, angle, side. So we can state the triangles are congruent by side angle side. We're wrapping it up. Triangle JKA is indeed congruent to triangle NKA by side angle side. All right, that's it for today. Have a good one.